Okay. Finally. Okay. Finally. Hello. Oh. Welcome to the session 4 of Stackschool. I'm Kayla, and today I'll be presenting with Anakin to talk about servers. And here's the link to the slides and the link to the demo. And if you do the ACM member portal, it's can you serve for today. And a quick announcement, Hoth 11 is coming up, and it's our 12-hour beginner-friendly hackathon that we put on every year, and signups are actually open right now, so you can scan this QR code, and applications are due February 26th. Yeah. So I highly encourage you to fill it out right now and tell everyone you know to do so as well. Oh, and it's on Saturday, March 2nd. Yay. And we'll be continuing off of what you've been learning the past few weeks. And specifically for today, we will be giving a brief introduction to servers. We'll talk about HTTP, web APIs, server implementations, and we'll give a demo on using it for your app. Okay, so starting off with some motivation for our Sounds Right app. So if you look at this picture, it looks great and amazing, but if we want Sounds Right to make it big, oh yeah, I'll post mine. Wait, no, she's on. Oh wait. Oh, is it? I think it's that thing. Yeah. Okay. Oh yeah. Yeah, something like that. Wait, I'll send it right now, and then you'll be able to get it. Oh. Oh wait, I'm fucking stupid. Oh no, I'm not stupid. Wait. Where is it? It says talking Kayla in the top right, so I thought it was okay. How do I? Is it? Oh, there it is. Okay. Going back. Oh no, now I'm like awkwardly. It's fine. Press escape. Okay. What was I saying? Oh yeah, so we want Sounds Right to make it big, and if we want it to take over the world, we're gonna have a lot of users using our app, hopefully, but we don't have a way for this to work. So if I wanted to click this like on the Polaroid love post, we want other users to be able to see that someone has liked that post, and if I wanted to make my own post, we want everyone else to be able to have it updated for them and be able to see my posts and interact with it as well. And so far we haven't set up a way to do that. And so now we will introduce servers. So since this whole workshop is on servers, what even is a server? You might have heard people say the server is down or something, but for our purposes of working with an app, how should we define it? So you can kind of think of it as a computer that provides services for other computers, which we'll call clients here. But you probably can't do much with just that. So a server has a special role of responding and fulfilling requests that are sent in by other computers or clients. And this server processes and retrieves info and does whatever it needs to best fulfill this request, and it sends a response back to the client. And you might have heard of servers, and you may think about these physical rows of computers in a dark secret server room or something. But like I mentioned before, it's more of a role that a computer takes, so it can be your very own computer as well, as long as it is listening for and responding to requests. And so for this restaurant analogy, imagine you are this person who came to McDonald's Deluxe, and it's Deluxe because this is a sit-down restaurant for our analogy. And you came to McDonald's Deluxe because you obviously want something. You want some food. You want to order food and get food. And so in this analogy, you are the client. Yeah, you are the client in this analogy. And so a waiter comes over and takes your order. And this is the process of you submitting an order or like a food request. And this waiter is a, a part of the server, but there's another part as well, as we'll see here. Because the waiter goes back to the kitchen, submits your order. All of the cooks do what they can to prepare your order as much as they can, and they send it back out. And this kitchen is also part of the server. This is where the part where the server processes your request and does all of the behind the scenes stuff that it needs to do before it sends back the response. And the response here is you getting your food, your fries, and the drink. And you've just been waiting here this whole time after sending in your response, and you get what you want. But just keep in mind that it doesn't always work out this perfectly. And so going back to actual servers, if you look at this picture, the server is the centralized machine that all of these different clients can connect to over the internet or a local area network. And through these arrows, they are all separately sending in requests and separately getting back responses. And these different clients can be your phone, your laptop, or a desktop computer, etc. And we call this the client server model. As you can see, these different clients are connecting to the server, and this is kind of what I've been describing up until this point. But how does the server know what a client is saying? Because if you think about it, there's going to be so many clients that are sending requests to a server. So we want a standardized way for the server to be able to see a request and quickly be able to process what is going on and what it's being asked to do. And so that is where HTTP comes into play. And HTTP stands for Hypertext Transfer Protocol. And yeah, I define protocol as a set of rules that allows transmission of information. And so with HTTP, the client sends HTTP requests to the server, and the server returns HTTP responses to the client. Again, what I've been describing, but adding the HTTP just indicates the standardized format that is used. And we'll take a look at what these actually look like. So this is an example of an HTTP request. And you can break it down into different parts. You can see the start line on top, the different headers here, and then this is just an empty line, and then the body. And looking at an actual response, it has a very similar structure, as you can see, but we'll go more into the specific anatomy in the next slide. So yeah, like simplifying it down a lot, this is the anatomy of a request. So you start off with a start line or a request line, and this is broken down into 3 parts. The first part is the method, and a method indicates what action you want to be taken from the server. So here we're using a get method, and this is pretty self-explanatory. You want to get something back from the server. And the next part is the target. So in this situation, since we're using a get method, this is what we want to get back. We want to get this PNG image. And the last part is the version, and it's just the HTTP version. And yeah, looking back on the actual example, you can look at the start line here. It's different. It's a post method, and we'll talk about more like about specific methods later. But this one, the post method, is more about you're sending in information, like you're making a post. And then next we have the headers. So there are typically a bunch of headers, and these provide additional information for the server so that it has more information on like what the context of the request. And An example of this here is user agent, and it's like, oh, you're using a Mac and you're using Firefox for your browser. And then lastly, we have the body, which there's typically nothing in the body for a get method because the body is like what information you're sending in, and if you're getting something, you're not sending anything in really. And then a response, again, is pretty similar. The start line starts with the version. It then has a status code, and the status code indicates like how well the server did. And I'll talk about the specific status codes in the next slide. And the status text is like how you should interpret this code. So in this case, it's not found. And then again, it has headers for information and a body. Since in this example, we're using get method, the body has the file or resource that you requested. And like I promised, here are the different types of status codes. We have in the 100s, it means informational, 200s, success, 300s, redirection, 400s, client error, and 500s, server error. And the most important ones probably are, if you're in the 200s, yay, you're probably good. But if you're in the 400s, there was an error on the client side, and 500s, it was a valid request, but it's an error on the server side. And so you've actually have seen this before, I'm assuming, when you see the 404 page not found page. And this is a status code like you saw before. And if you remember, 400s means it was a client error. So you requested a page that the server cannot find anywhere. And so like if you go to Google and you request bad page, it's going to tell you like it was not found on the server. They can't show you a page. And then this is more of a side note, but since you'll see this later on in the workshop, I just wanted to introduce JSON. So this stands for JavaScript Object Notation, and you can just think of it as a way to represent data that's like a specific format to represent data. And this is important because say there's like different types of programs or systems that want to share information, and you want it kind of like the same idea I mentioned before, but you want it to have a common language so they know how to organize, understand, and exchange data. And yeah, it's as you can see on this example, it's quite easy to like understand the data. Okay, so I will be giving a quick example on looking at real life HTTP requests. Oh my God, so many tabs. But if you open a new tab and you just right click anywhere, you can go down to the inspect button. And whoa, this pops up. But you can go to the fourth tab. Oh my God, this thing is covering it for me. No. Okay, and then go to any website of your choosing. Oh, I cannot type. So I will go to YouTube, the ACM YouTube channel. And as you can see, all of these things popped up. So what I did is I just requested a web page, this ACM YouTube page, and in doing so, all of these events fired up. So at the bottom left, you can see that 99 requests were made, and oh, it went up. And here you can look at the status codes, and what kind of happened is you requested the page, and so it was reading this HTML file, and it because of that requested all of these different things like images and etc. But if you click on a specific one, you can see everything that I kind of mentioned before. So you see that this is a get method and it has a 200 status code. So it is okay. And here are like the request headers. So again, the user agent, I'm using a Mac and I'm using Chrome, and response headers. And yeah, you can just do this with any web page of your choosing. And like I mentioned before, like this is a JSON one. and it like looks very similar to my example. But now I'll pass it off to Anakin to continue with APIs. How do I? Okay.
I cannot screen share. All right. Thank you, Kayla, for the wonderful presentation about HTTP. Now we're going to get into a little bit more about some topics that you'll be able to use to actually code up your own web server. So to start it off, let's go back to the restaurant example. For the haters, this Shutterstock image was in last year's workshop, and I intend for it to be in next year's too. So no hating. But if we go back to the restaurant example, in this case, the guy sitting down would be the client, and the server would be somewhere in the back, represented by the kitchen. And now with HTTP, um, we have a way for our customer and our kitchen staff to speak the same language, so they can transfer data between each other using HTTP. But how does the customer know what they can actually order from the restaurant? And of course, in real life, that's where the menu comes in. But we're not here to open up a milk tea shop, right? We're here to develop an application. So how does this relate to web programming? And the way that you can think about this is that a menu is the most similar to an API. And API stands for Application Programming Interface. It's simply just a contract between two applications that dictates what form the data will be sent in, how it'll be sent back, and what operations the client and the server can perform. So in our case, the two applications that we're working with are the client and the server. And specifically today, we're going to focus on web APIs. If you just Google about APIs and try to read up, like the term API predates the internet. So you'll see like a lot of stuff about like random Java APIs and stuff like that. But the terminology for today is all the examples are going to be using the RESTful architecture for web APIs. So this is just one method of designing APIs. And if you want to slap something on your resume, then the keyword would be RESTful API or REST API. So you can do that after today. And the way an API works is that it contains several endpoints, which are just URLs that indicate what the server can do. For example, if we wanted to make an endpoint that corresponds to this milk tea menu, we could have something like this, where we have a GET request at the URL /milk_tea/taro/medium. And what that might do is it might return to the client a bunch of data about this specific milk tea order. And the way that this works is that when the client visits this URL, it gets mapped to a function on the server, which is literally just JavaScript code that you write. And if you want to read more about this, this content and more can be found on the AWS website, and it's linked on the bottom of the slide. So when we're developing an API, we have to think about what kind of operations we might want to support. And the way that developers like to think about this is through this acronym called CRUD, which stands for Create, Read, Update, Delete. And as you can see, these CRUD operations conveniently map to the HTTP methods that we learned about before. So I'm going to review the HTTP methods real quick, and then we're going to look at a real life example of how we might apply these principles. So as we looked at before, real quick, the GET request retrieves data from the server. The POST request is used to create a new resource. The delete request is used to delete data from the server, and the put request is used to overwrite or update a resource. And there's a bunch of other ones that we won't be touching on that you can read more about on the Amazon website. All right, off to our real life example. This is a sneak peek of a workshop we'll be doing later with Spotify API integration, so make sure to come out to that. But so for our industry example, we're gonna look at the actual endpoints from the Spotify API and think about how if you were an engineer at Spotify, how you might want to design it. So the first question we're asking ourselves is what endpoints might we need? And then following from that, we want to ask ourselves what methods might they use? So one of the functions that Spotify has is that if you open up the homepage on the app or on the website, it shows you a list of new releases. And in order to do that, we want an endpoint, of course, that when you query it, it returns all the new releases. So since we're retrieving data from the server, we would make that a GET request. And we could make the URL /browse/new releases so that it's recognizable and it makes sense to other developers. And then furthermore, let's say we wanted to get a playlist. Same thing, we're retrieving data from the server, so we would use a GET request. And for our URL here, we could use /playlist/ the ID of a playlist that denotes the specific playlist we want to receive. And moving on, for creating a new playlist, that's creating a resource, as we discussed earlier. So you would want to use a post request. And then lastly, to delete a song from a playlist, you would use a delete request. And a little bit more about these URL parameters here. Basically, there's two kinds of routes or endpoints that you have to pay attention to. There's static routes where the URL always stays the same, just like the first new releases endpoint. And there's also dynamic routes, which contain arguments that change. So with dynamic routing, basically like for the playlist example, you can slap in an ID like /playlist/1 or /playlist/2, and it'll only return the data for the specific playlist that you want. So that's going to come in handy for us later. Testing APIs. So there are a couple ways that I'm going to go over to test APIs. The first one is curl, which is built into the terminal. You can use that if you're a psychopath, but I recommend Postman, which gives you a really nice interface for testing your API. Both our tools are widely used in industry for various reasons. Like curl is just easy to copy and paste terminal commands and share them. And Postman has really great collaboration features. So I would recommend looking into them in your downtime. But testing in Postman is really simple. If you go ahead and download it, you'll be presented with this window here, and all you need to do is create a new tab, paste in the URL you want to use, select the method, and then if you want to do a post request, then you can just select raw, select JSON, like I have boxed here, and then you just put in your post data and you're good to go. So that's just Postman. It's pretty intuitive. I think if you download it, you'll see what you need to do. Curl is a little bit less intuitive, but I know there's some people out there who think that downloading programs is too high effort. So the great thing about curl is that it's built into every single computer when you first get it. So all you need to do is you open up the terminal and you type this curl command. So for get and delete, or the format of a curl request is just the curl keyword, -x, the method, and then the URL. And then there's a little bit more for post request because you have the JSON body. But other than that, it's pretty simple. You can, if you want to, you can feel free to copy paste the curl command off the slide and then just replace the URL and the JSON body with whatever you want. Now that we have, now that we have that skill, let's try a little bit of a fun activity. This should take about 5 minutes. I've included a link to this deck of cards API, and if you go in there, you'll see a list of all the different kinds of endpoints which correspond to the operations you can do on this deck of cards. And what I want you to try for the next couple minutes is to use either curl or postman to create a new shuffle deck of cards and then draw a card and see what you get. So let's give that a go. And if you have any questions, raise your hand and officers will be looking out. Oops, that's the answer.
Wow, this guy made the computer engineering for babies.
Oh, he did?
I kept getting asked for that on Instagram.
That's pretty awesome. I didn't know that.
Targeted ads or no? You don't that one slide. I can say that you read
What? Which slide?
the crowd operations slide.
Oh, what? Because I ripped it from the image that Jenna sent me. I'm not an artist, man.
So
Like,
funny.
there's like a noticeable drop off in art from the first half to the second half of the presentation. Awesome. Oh, got it. All right. Looking good. I'm just gonna start doing the example in Postman here since it's pretty simple, and then I'll show the answer in curl as well afterwards. So if you're doing it in Postman, all you would need to do is from the deck of cards API, you're going to want to take I'm gonna expand my screen a little, cover my folders. You're gonna want to take the first endpoint here, which is the one to shuffle cards, or yep, and you just want to create a new deck and shuffle it. And so if you send that request in, you're gonna get a deck ID, and all you need to do is copy this deck ID, and then within the draw cards endpoint, which is the second one listed on the documentation here, you need to replace the deck ID with the one that you got from your previous request. So that would just look like this. And then if you send that in, you get a nice card, 3 diamonds, 51 cards remaining. You can draw it again, and now there's 50 cards remaining, and so on. So pretty cool. And if you want to do it in curl, this is how you would do it in curl. You could just copy paste the first command into your terminal and then take the deck ID from the output and paste that into the second command and just run that in your terminal as well. And that would have the exact same effect. Awesome. Any questions about the activity? Okay, moving on. Great work. Now we're going to talk about how we can actually code our own web server. In order to do that, a little bit of a review of what Node is. Node is defined as an asynchronous event-driven JavaScript runtime designed to build scalable network applications. And that's kind of a mouthful, so you can think of it as a runtime environment, which is the space where your code can be run, sort of like what the Java virtual machine is to Java or the Python interpreter is to Python. It just allows you to run JavaScript code on your computer. Next, in order to develop our web server, we're going to be using a framework called Express. So Express is a minimal and flexible Node.js framework that provides a robust set of features for web applications. And a framework is just a library or a collection of code. So pretty much we're going to be using code that someone else wrote in order to speed up the development of our own API. And that is the most common use of Express, which is designing APIs. To use Express, I prepared a little bit of a cheat sheet here where to initialize Express, all you have to do is create a variable and set it equal to the Express object, and then you just set app.use express.json, which tells your application that you want to take your responses and requests in JSON, and then for the last line, it's just the app.listen just tells your server which port to listen on. So if you use port 8080, then you can send your request to port 8080 and your server will respond, hopefully. This is a lot of stuff, but I've ripped an example from the demo that we're going to talk about to show you pretty much how to build your own endpoint in Express. Don't worry about understanding every single part. The idea here is more that you'll be able to take what you learned today and understand enough that you can adapt this to fit your own personal project or your 35L project. But essentially, what this is doing is app.post. The post is just the HTTP method that we talked about earlier. So if this was a GET request, you would just replace that with GET. The first parameter in the function is the endpoint, and that is just the URL that you want to map this function to. Next is the next parameter is a function that takes in a request and a response. So the request REQ is just an object containing your request body or parameters. So the body would be like the JSON that we were looking at earlier for post requests. And then res is just the object that you're going to use to send back the response. So if we look at the anatomy of the code here, pretty much what we're doing is we're making a SQL query. In that query, we're replacing the values $1, 2, 3, and 4 with the 4 values that we got from the request body. and then we're calling res.json in order to return a response that is just a JSON of the new song that we added to the database. So yeah, it's a lot, but I'm gonna be showing you an example later, and hopefully you'll be able to take this with you to adapt your own code. So now it's time for the demo. I'm going to be picking up from where we left off in workshop 3. So if you haven't done so already, what you'll need to go to the backend folder within your project, and you'll need to install Express, PG, and NodeMon. These are 3 libraries that we're going to be using today in order to set up our API. And also, if you haven't done this last workshop already, then you're going to want to add a user to your database, or else you won't be able to test any of the queries. So you can just copy paste this from the slides into your Postgres terminal, and you should be able to create a user like that. All right, it's time to code. This is visible enough. One more. All right. Dude, where's my other workspace? Okay, we're cool. We're cool. All right, so the first thing we're going to do is that you're going to want to switch into your backend directory. So you can do that in the terminal using cd, and we're going to install node packages in here. So to do that, we're going to start off by doing npm init to create our package.json and packagelock.json. You can just press enter through this, and you'll see that it creates a new package file. And now we can do npm install the 3 packages that we need. All right, easy enough. And one more thing you might want to do for convenience is within package.json, I just clicked it in the file explorer here. You can go to scripts, and within scripts, we can create a new script, which we'll use to start our server in the future. And you can just type nodemon index.js like this, so that in the future, when we create this index.js file, you'll be able to run it by doing npm start. Cool. So now let's create that file. So this file that we're creating now, index.js, is where all the code is going to live for our API. And in order to get started with that, we first have to create our Express app. So I'm pasting in the example from the slides here, which is just this. And all this is going to do is it's going to create a new Express server on port 8000. So if we run npm start now, awesome. Please import your packages, guys. So we're going to slap this down so that we actually have access to the Express module. And then NodeMon will automatically run this again. Well, I'm going to just npm start. And then as you'll see, our server is now listening on port 8000. So we successfully, with only these few lines of code here, we successfully have a server that does nothing. Let's make our first endpoint. In order to do that, we're going to need to access the database. So we're going to have to create a new file within our backend folder. We're going to call it db.js. And this is just going to, db.js. I created that inside of the backend folder, and this is just going to contain the configuration so that our server can connect to our database. And I'm just going to, you can see on the slides what that's supposed to look like, but I'm just going to paste in the configuration that I want. And pretty much all this is your Postgres credentials. So that would be your username, your password as you created it last workshop. the name of the database, which is SR database. The host is just localhost, and the port would be whatever port you configured your database to run on last time. So for me, that's 5432. And now that we have that set up, we can get into actually creating our endpoints. And the first one we're going to create is a nice and simple GET request. We're going to create an endpoint that gets all the songs in our database. So let's try that. Like we saw on the slides, we want to start with app dot and then the kind of the request that, or the method of the request that we're using. The first parameter is the endpoint. I'm going to do /song/all in this case. And the second parameter is a function that takes in both the request and the response. And then, cool. So the first thing that we're going to do is that we're going to create a try catch block. This is a common pattern that we use, such that if there's any errors with the request, we'll be able to log them to the console and see what's going on with our server. Awesome. And now in the try block, we're going to use the PG library that we downloaded earlier in order to make a query to the database. So before we can do that, let's not make the same mistake as earlier, and let's actually include our database file. So all I did here is I added this require statement on line 3. And then from there, we can use pool to make a query to our Postgres database. So that would look like this. Pretty much all this is doing is that we're defining this variable called all songs, and we're using the function pool.query, which this is what you're going to use every single time pretty much when you want to query your Postgres database. And from there, you just type in the SQL query like you learned it in the last workshop. And we're going to return all the rows that this query retrieves. So now we can test to see if this API is working in Postman. It's a good sign that we have no errors in the console so far, but you never know with these things. So, ooh, I'm not sharing my Postman. Looks like we're. All right. So going back to Postman, I've already prepared my testing setup for this /song/all API. And if we send the request, we can see that it doesn't work. Awesome. I probably did, to be honest. Yeah, I hate typing, man. I'm just gonna copy paste it next time. But yeah, so now if we send it, we see that all the songs that are in my database are returned to the user. So that's pretty cool. All right. So returning all the songs is pretty fun, but let's say we just want to return right now your database is probably empty. So if you try to return a song, you're not going to get anything. So why don't we make an endpoint that allows us to add a song to the database? So the way that we would do this is following the pattern before, the method here would be post because we're creating a new resource. I'm going to call this endpoint /songs. And I'm going to pass in a function that takes in a request and a response. And we're going to pop a try catch block. Yeah, as you can see, like backend programming can be pretty repetitive, but once you understand the patterns, it's pretty chill. So for this, the first thing that we're going to do is we have to get the data for the song that we want to add to the database out of the request body. So to do that, we're going to use a feature of JavaScript where we can destructure the object like this to get the artist title and user ID fields. And this will just parse those 3 fields out of the request body JSON. And then from there, we want to keep track of when this song was added to the database. So we can pop in this current date equals new date line, which if you just put no parameters in the date constructor, that's just going to return the current date, which is what we want. And finally, to get the new song, we're going to do the same thing as last time. There's kind of a pattern developing here where we just have we have our new song variable. We're setting that equal to our pool query, and we just type in our SQL query here that will insert the song into the database. And just a quick recap of what's going on here. Within the query, these values with dollar signs in front of them denote like parameters that are going to be replaced, and those get replaced by the 4 values that you pass in the array here. And then after the returning, this just denotes what fields the user will get back so that they can see whether their song successfully posted to the database or not. So no errors is a good sign. Now if we hop over to Postman and we try to run this, I already have my body set up here, so let's change up the title so we can see a new song in the database. And if we send it, we see, boom, we have a new song in the database with an ID of 18, title, talk that talk, date, right now. And if we call the songs all endpoint once again to list all the songs, our new guy's right here at the bottom. Pretty cool. All right, I'm hopping back over to our code. Okay, so now we have a way to list all the songs and a way to add a song to the database. So we're going to implement 2 more endpoints here before I leave you to do the rest on your own time. But the next thing that we're going to do is it would be pretty useful if instead of listing all the songs at once, if we could just get the data for a single song. And the way we're going to do that is by the song ID. So all right, we're actually going to delete a song first, guys. But it's the same thing. Yeah. So I'm just going to demo how to delete a song by ID. That way we can get rid of the songs that we don't like. And the way that we do that is, again, we're following the exact same pattern. So app.delete, since we're doing a delete request, and then we pass in, I'm just going to copy paste the last one. But we just have our endpoint. So in this case, we want to do /songs/delete. And because we're deleting a specific song, we want to add in a parameter. And the way that we do that is we just put a colon and then the name of the parameter that we're using. Our try catch is already in place. So all we need to do is get the ID of the song we want to delete out of the parameter. So the way that we would do that is using the request object like this on line 38. Very similar to what we did before. For the query, we're going to use pool once again. And we're going to call this delete function, or we're going to use SQL and just call delete from songs, passing in the ID that we got from the request parameters. And then if that works, we'll return the response that the song was successfully deleted. Another thing you can do, there's like no clear documentation about exactly what you should return for delete, but another common thing to return is just whatever the deleted object was. So you can do that optionally as well. So if we hop into Postman again and test this delete endpoint, So first let's call let's look at the result of our song/all endpoint here to see which song we want to delete. I like all these songs, but I guess we'll just delete this one. So ID number 16 is going. So if we pop that into here, what we should see is that song was successfully deleted. And then if we call this /song/all endpoint again, we'll see that the song with ID 16 no longer exists. All right. Let's hop back to the slides for a second. Yeah. So all the code for the stuff that we went over today and a little bit more. Oh, do you have a question?
Oh, you're talking.
I'm talking. What if I'm muted though? All right, we cool. We cool.
It's the audio for the ABS, but the ABS isn't like.
Yeah, we don't use that, right?
Yeah.
Okay, yeah, but all the like all the code for the demos that we went over is in the slides, and there's even more in the GitHub, but pretty much like that's the general idea of how you would create these endpoints. All of them are just following a pattern like we saw. Um you learned today how to destructure the request parameters and the request bodies so that you can pass data to the server. And with that, you should just be able to like copy paste and modify until you win pretty much. So but yeah, there are way too many endpoints for an app like this to implement in a demo at the end of a workshop. You'll come to find when you do backend programming, it's very repetitive. Like I said, you're gonna have to implement like tons of endpoints like these over and over, and it's a lot of copy paste. But if you want to follow along more with Sounds Right development, feel free to check out the GitHub and look at the rest of the endpoints. You can try giving based on the descriptions, you can try implementing them yourself, or you can just clone it. So I linked it here. And that's pretty much everything. Thanks for coming. Next week, we'll be integrating the front end with the back end and doing some user authentication. Ooh. Awesome. I'm stopping the share.